Before we get into the meat and potatoes of all the ideas we're going to talk about, we have to introduce the basic idea of a dimension. A dimension is just another word for direction. Left and right is one direction, forward and back is another direction, up and down is a third dimension or third direction. We're all familiar with that. We wake up in a three-dimensional world every day. In mathematics, one dimension is independent from another when one direction is at a right angle to another. And a right angle is just the corner of a piece of paper. And the way I think about it is if you're going into your kitchen for a delicious snack and you see exactly the thing you were hoping wouldn't be eaten. Left and right is one dimension and forward and back is another dimension. They're independent, and what that means is you can go left and right as far as you want. You can go left to the next town, the next country, or the next galaxy. But you will never, ever get that delicious food that's right in front of you. When we wake up every day, we live in a three-dimensional world, so we have the ability to move along forward, back, left, right, and up and down. If you wanted to get anywhere in the universe that we can see, anywhere in the visible universe, all you have to do is go a combination of these three directions. In order to understand the basic idea of what we're going to be talking about, it's useful to have a metaphor or an analogy. Instead of talking about four-dimensional mathematics, we're going to bring it down a notch into three-dimensional mathematics, which we can visualize. I'm about to tell you a story about a blanket floating in space. And it's going to seem bizarre at first, but the purpose of talking about a blanket floating in space is that you can picture a blanket floating in space. What you can't picture is a fourth dimension. Throughout each concept that we touch upon, we can return to this lower dimensional blanket metaphor. So while it might seem bizarre at first, and it will be bizarre because there's weird aspects about it, it will be useful throughout the rest of what we're doing. The basic idea goes like this. Imagine you're floating out in space and there's nothing around you. Moving through space like you have a little rocket, you can just zoom around in your imagination. Until you see what appears to be a wall floating as far as you can see in all directions. As you get closer, you realize that it's not a wall, but a blanket made out of strings. Woven into the surface of the blanket are patterns, just like patterns can be in a rug. The patterns are of galaxies, and as you get closer and closer, you realize that the galaxies are made out of smaller, flat stars. And orbiting most of the stars, there are flat planets. And then you realize that, unlike a rug where the designs stay stationary, the strings are moving and interacting with each other, meaning that it's not a static wall like a painting, it's a dynamic blanket. Out of all the blanket stars and blanket galaxies, we're going to look at a blanket planet called Blanket World. Blanket World is populated by blanket people, and blanket people appear strange at first because they're flat. They're almost like cartoons if you were to draw them on a piece of paper. Kind of like a video games like Super Mario, where the character in the video game can only go left or right or up and down. The blanket people are made out of the strings that are the blanket. Their bodies are made out of billions of tiny, 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 tiny little strings. And since their bodies are within the blanket, they can only move forward and back and up and down. When they open their eyes in the morning, they only have the options of going forward and back and up and down. Light in the blanket universe is ripples that travel along the surface of the blanket like ripples on the surface of a pond. So when blanket people open their eyes, the light that they see is ripples that have traveled along the surface of the blanket into their eyes. They've never seen or experienced a third dimension. They only believe in what they see, which is the two-dimensional world that they live bound within. 100 years ago, there was a strange blanket person named Einstein. The blanket version of Einstein did something strange that no other blanket person had done before. He wrote a theory using the two dimensions that everybody's familiar with, but then he added a third and labeled it T for time. At first, people ridiculed Einstein, saying, well, what are you, open your eyes, there's only 2 dimensions. Nevertheless, over time, as technology advanced on Blanket World, more and more experiments could be done until they tested that Blanket Einstein's 3-dimensional mathematics actually represented reality better than not including the 3rd dimension. For 100 years, all of the Blanket people used 3-dimensional mathematics, but they don't believe that the 3rd dimension is actually physically there. As the years passed, Einstein's theory was proven correct over and over again. But eventually the technology on Blanket World that was partially helped by Einstein's theory was able to make these incredible telescopes that never existed in Einstein's day, and incredible microscopes and particle smashers in order to probe deeper and deeper into the reality of the blanket that surrounds the Blanket people. And as the decades passed, trouble began to brew in the realm of theoretical physics. This trouble came in the form of experiments revealing things and revealing behavior of galaxies that is not predicted by Einstein's theory. One of those has been named dark energy, another one has been named dark matter. Those are just 2 of multiple phenomena that started off quietly with an experiment here and there and eventually became more and more profound until every single physicist could not deny that there were fundamental problems in the physics world. Another one is the laws of physics are not united in Blanket World. Einstein wrote the physics of the very big, and quantum mechanics is the physics of the very small. When Blanket people try to combine them, what they get is haywire mathematics that don't make any sense. Einstein actually spent the last decades of his life trying to combine the theory of gravity with the theory of the other forces. He never did. About 100 years after Einstein was born, there was born a Blanket person named O. And as a kid, O loved spending time in nature. And at night, when the stars came out, O would look up into space and think, what is going on up there? One day when O was 13, O was given a book as a present. The book was about an odd group of Blanket people called physicists. O realized that these people were asking the same questions that O had wondered about. And not only did they ask questions about the universe, but they actually found some answers to their questions once in a while. O had heard the name Einstein before, but O didn't know what any of the ideas were about. The reason why Einstein became so notorious was not because his ideas were overly complicated. It was because his ideas were reachable. Einstein was a theoretical physicist, which is basically using structured imagination. Instead of doing experiments on a table, you do the experiments in your mind. To test whether what you're seeing in your mind represents reality, there's another group of physicists called experimental physicists, and they build things like telescopes and microscopes to test out what the theoretical physicists dream up. Experimental physicists basically provide the tether to reality that theoretical physicists need, because if you don't compare what you're imagining in your brain to experiments, it's very easy to get lost. The whole reason why theoretical physics works is because theories that are accepted are the theories that agree best with experiment or observation. A theory has to align with reality completely. Einstein's description of the universe was 3-dimensional, which O didn't understand what a 3rd dimension could possibly mean. O lived in a 2-dimensional blanket. But nevertheless, all of the ideas that O was exposed to in Einstein's theory could be imagined in your brain. They could be pictured. Very quickly, O became pretty much obsessed with Einstein's theory and spent the next 6 years reading nothing but theoretical physics books. O was mainly fascinated with one question in Einstein's theory. Einstein derived all of relativity using 3 ideas. The first idea is that the laws of physics are the same everywhere. If you do measurement in one place and then do a measurement in another place, you're in the same world. So wherever you go in the blanket, the physics are the same. The third assumption is that the speed of light is constant. O became ever more fascinated with light and why light is so important and why is it everywhere in theoretical physics, not just in theories that Einstein wrote. And why is it the speed limit? Why can't anything go a little faster? Or why is it that number? O went to college with the idea of trying to figure out why light speed is so important. O graduated from college and still could not understand why light speed was fundamental and everywhere. Over time, O became more and more demoralized until O began to doubt whether the entire endeavor of trying to understand reality through theoretical physics would even work and whether it was just a waste of time. And maybe even Einstein's theory was just chicken scratch and like a game compared to what's actually out there. In that moment of doubt, O was also in a moment of openness. And when you're willing to doubt anything, you're willing to accept anything. O looked at the third dimension from a new perspective. O thought, what if everybody's wrong about the third dimension? What if the third dimension is real? Within a day, O figured out why light speed is the fastest something can go. That freaked O out because O had been trying to figure it out for 12 years. And the way O figured it out is by treating the third dimension as if it's actually there. The third dimension in blanket theory, if you remember, is labeled T for time. Time is everywhere in physics too, because physics is just things moving around in space and time. So whenever you have things moving around, time is relevant. Which means if the third dimension is real, then O would have to go through all of theoretical physics, reinterpreting the mathematics, assuming that the third dimension is actually there. What O did not expect was for other phenomena like dark matter and dark energy to fall out naturally. O started figuring out explanations to phenomena that O was not trying to solve. O was just checking whether the third dimension being real makes sense in different contexts. The single idea, the one sentence that the time dimension is real, was a skeleton key to start unlocking phenomena that O never dreamed of ever understanding. The problem with theoretical physics is that it's structured imagination, and you can't share your imagination with other people easily. A musician can write a song and share it with somebody. A painter can paint a masterpiece. O was trying to figure out a way to express what O was seeing in the thought experiments to everybody, not just theoretical physicists. The biggest problem was that blanket people can't see the third dimension because they live within the blanket. So then O created a lower dimensional metaphor that the blanket people could picture. The description of people living in a blanket is the lower dimensional metaphor for our world. In other words, I'm O, and I'm telling you that if the fourth dimension in Einstein's theory is real, then Einstein's theory was correct to include it, but wrong to assume that it's not actually there. But instead of a two-dimensional blanket moving through three-dimensional space, we live in a three-dimensional blanket moving through four-dimensional space. And in the context of the history of science, this follows the pattern. And what I mean by the pattern is that at the beginning of science, people thought that Earth was everything in the universe. And then they realized that Earth actually exists within larger space and it's moving through it around a sun. Then they thought, oh, well, that's everything in the universe. And then they realized that the points of light they see in the night sky are other suns in a much larger galaxy spinning in even larger space. And then a guy named Hubble came along and said, I've got a pretty strong telescope over here and I'm pretty sure I can see other galaxies. And then the view of everything became billions of galaxies. And what I'm telling you now is if the fourth dimension is real, then the next step in that pattern is that everything we see when we open our eyes is a three-dimensional blanket in larger space. The blanket people can't see the third dimension beside them, and yet it's still there. Then assuming the fourth dimension is real, just like the blanket people, the edge of the universe isn't some place beyond the farthest stars and the farthest galaxies. It's right beside all of us, just like the third dimension and empty space is right beside all of the blanket people. Now, hearing this for the first time, without hearing the explanations of all of the other phenomena, I would expect you to think that I'm a little bit crazy right now. But in the next video, I'm going to explain every single claim in a way that both physicists and non-physicists can understand. By having listened to this video, you've been introduced to the groundwork of the blanket metaphor, which we will reapply again and again and again to solve previously disconnected phenomena using the same singular assumption that the fourth dimension is real. The following list of phenomena that I'm about to name, you don't have to understand what each word means, because you won't unless you study physics. And that's okay, because we're going to explain the context of each problem, why it's a problem, why it's unsolved, and how assuming the fourth dimension is real resolves the issue. We're going to go through dark matter, dark energy, what is time, why does time only flow in one direction? We'll go over that. The missing antimatter problem. We will derive gravity using elementary particle interactions. And a theory in which gravity is united with the other forces satisfies the main criteria for what physicists call a theory of everything. But we're going to do it by assuming that there is much more to everything than we can see, because our primary assumption is that the fourth dimension, already present throughout mathematics and physics, is actually there. And I don't expect you to believe that the fourth dimension is real in the context of one solution. But in the context of dozens, it becomes overwhelming. At the end, we will have two incompatible views of the universe. Either the fourth dimension is real, or it is not. The last 100 years have laid the groundwork for a theory in which the fourth dimension is not real. But after we go through the aforementioned phenomena in the next video, what we have is a perspective of the universe which diverges from relativity but agrees with observation in a way that relativity falls short. But if you've listened this far, I'm already proud of you. And if you felt a tinge of fear or anxiety by any of the ideas that I've mentioned, I want to tell you that I felt them too, and that it took me 2 years to wrap my head around the ideas that will be expressed in the following video series. And while some of the ideas to come are jarring and unnerving, there are other ideas to come that are beautiful. So if you come with me, we'll explore all of these ideas. And if the fourth dimension is real, we'll get glimpses of something that has always been true. And just as in the history of science, we will again realize that the world is not what it seems.